All right, answers. So the intact balloon represents your lungs. There's not two. It seemed really difficult to be able to get two in there and using the same airway. So just use one. So the diaphragm moves down, the lungs inflate. Cool. And notice how they're not touching anything. It's all being done by pressure differentials. What does a straw represent? That's the trachea, right? You've got this kind of solid structure. This is too solid, right? Remember, the trachea has rings of cartilage. But this is the trachea. Comes down, provides structure for the airway, moves down. The lungs branch off from it, or in this case, the one singular lung branches off from it. And there you go. All right, when you pull the diaphragm downward, what happens to the volume inside the bottle? Well, so if I cap the volume at this point, it's it's a constant. It's one thing. As I pull this down, the volume inside the bottle increases, right? Because this is staying in the same place. Nothing's pulling in. Nothing's deforming. So the volume is increasing when I pull down on the diaphragm. So you're ending up with more volume. What happens to the pressure inside the cavity of the bottle? Well, think about Boyle's law, right? So volume increases, pressure decreases, right? Because they're going to multiply together to form a constant all the time. One gets larger, the other one has to get smaller. So volume increases, pressure is going to decrease. That is called negative pressure. Why does air flow out when you release the diaphragm? Because the volume is decreasing now, right? So I push in on this, the volume decreases. Volume decreases, pressure has to increase. So now there's less pressure in here. Now there's more pressure in here when I release it, like that. So pulled, less pressure, I let go. There's more pressure inside. That pressure is pushing on the balloon and forcing the air out, right? All right. Let's think about air pressure in the balloon or the lungs compared to the atmosphere outside the balloon before manipulating the diaphragm. What is the atmospheric pressure compared to the alveolar pressure? So right now, in this state right here, the atmospheric pressure and the pressure inside this lung balloon are equal. So it kind of looks like it's deflated, but it's not. It's got a little bit of air in it, but the pressures are equal. Nothing's happened yet, right? So the next question in number 6 is kind of it's not necessarily a trick question. It's just got kind of multiple answers going on at once, right? So the diaphragm is contracting and it's pulling down. You end up, the lungs inflate, right? So the reason for this is there's lower pressure in here. That means at this instant, there's lower pressure in the lungs than outside, so air's flowing in. By the time I get to this point, everything's equal again. So it kind of depends on what moment in time you're talking about, right? At the exact moment that this is contracting, you've got higher pressure outside, so atmospheric pressure is greater. While it's contracting, you've got higher atmospheric pressure. But as soon as you're done, everything's equal. And then you relax, then pressures start to get higher again until it's completely relaxed and everything's back to equilibrium. Okay, so for number 7, inhalation is caused by equalization of atmospheric and alveolar pressure, is the word that I'm looking for there. Muscular forces used to increase the volume of the thoracic cavity by raising the rib cage, so you can imagine that if there were actually muscles attached to this could raise up and increase its volume side to side as well as the diaphragm, and lowering the diaphragm is the last part of that question. For exhalation, the diaphragm is not contracting, it's returning to its original state, right? It's just kind of rebounding back to where it was. This is all a passive movement. There's no active forces at play. And then the lowering of the chest wall also is a passive movement in tidal breathing. If you're forcing air out, so if you go like that, that's going to be active breathing, active expiration. Maybe if you're speaking or something like that, or exercising, then you're going to recruit muscles to help push the air out. But if we're talking about just normal tidal breathing, it's going to be a passive force. Oh, so number 9, what other force is exerting a downward pull on the rib cage? Something that's not recoil? Gravity, right? That old jerk. And then 10, that's all done in another video that I will link at the end of this.